Okay, chapter 6. We're talking about random variables. We did a little intro last class. I told you guys random variables is going to have more probability. It's split, I would say, like 75% probability and numbers, a little bit of interpreting. So today we're going to do the background. What is a random variable? We'll talk about the difference between discrete and continuous. We'll look at some calculator stuff. What I want to show you at the bottom of this is a little bit different from the last unit, which was just normal probability. There is a bunch of stuff you need to know how to, bless you, do on the calculator. There are also a bunch of formulas on the formula sheet that will relate to this. We are going to learn the first two today, and then the calculator stuff we've already talked about, so we'll just review it again. If you can find this page. Okay, starting out with, what is a random variable? A random variable takes numerical values that describe the outcomes of some chance process. Chance process just means we don't definitively know the outcome. So the airline example, the number of people that show up for a flight, that's a random variable because we don't know definitively how many people will show up. What I want you to notice is that a random variable has to be numeric. So there are no categorical numeric variables. There are no categorical random variables. They are always numeric. Okay, the word distribution always has the same meaning. We've seen distribution before. Distribution always means it's a way to show the possible values or outcomes and how likely they are. So in this case, probability distribution is going to show the possible outcomes, like 180 people showing up, 181, and then the probability of each. That's the how likely part. It's the probability of each as a relative frequency. This can be displayed often in a table or a graph. In the video, we saw a graph. We saw the histogram. Okay. Discrete random variable. We talked about this the other day as well. A discrete random variable is numeric, and it takes on a fixed set of values. But those values can be infinite. On a number line, there will be gaps between those values. For example, if I asked you your shoe size, that is a discrete random variable. It can be 5, 5.5, 6, so on and so forth. If I ask you the amount of money you spent at the grocery store, that is discrete. Doesn't mean that it's a whole number, but you could not have spent $13.998. So whatever the values are on a number line, there are gaps of some size in between them.
You could spend $13.99.
You could.
But in the United States, money does not go past the hundredths.
Yep. The other option is continuous, which we will talk about in a minute. Questions on those before we look at an example? Okay. Here's the first example. Imagine selecting a U.S. high school student at random. To find the random variable x is the number of languages spoken by the randomly selected student. The table below gives the probability distribution of x based on a sample of students from the U.S. Census at School database. Okay, so first thing, probability distribution. It gives us the possible values of x and their associated probabilities. How do we know that this is a discrete random variable? How do we know this is discrete?
There is a finite fixed set of values because it's taken off of date. It is a fixed set of values.
Right, you can't speak 1.3 languages. A, show that the probability distribution is legitimate. We've done this before. All of those probabilities have to sum to 1. They do. B, make a histogram. I'm going to be honest, I don't really want to make a histogram. Are you guys comfortable making a histogram on your own later? Like, you can do that in the homework. We don't need practice. Great. What I do want to talk about is when it says describe what you see. What do we talk about in a histogram? There's an acronym we use because it's a univariate numeric data. Come on, guys. Yeah.
Is it FUDs?
Oh, it's not FUDs. What is FUDs for? But thank you for remembering that one.
When there's two variables and it's like
Scatter plot. When there's 2 variables, it's FUDs. What's the other one that we use every other time? Alan? CSSU. So you would use CSSU. What does C stand for? Center. S. Shape. The other S. Spread. U. Unusual. What are some things that could be unusual? Outliers, unusual observations. There might be a gap. So that's what you would talk about. Okay, C. What is the probability that a randomly selected student speaks at least 3 languages? So we are looking for the probability at least 3 languages, which is the probability of 3 languages, add the probability of 4 languages, add the probability of 5 languages. So that would be 0.075, I believe. When you have to interpret this probability, I do not want the word probability in your interpretation. I do not want the word chance. I do want in the long run, though. So we would say something like, in the long run. If we sampled many U.S. high school students, that's the long run part. That's what I really want to see, the many U.S. high school students. About 0.075, or you could write it as 7.5%, whichever you prefer, of them would speak at least 3 languages. Okay, in D, what is the probability that a randomly selected student speaks more than 3? So in that case, we only want 4 and 5. And that would be 0.010. What I really want us to notice is that our answer in C, so greater than or equal to 3, is not the same as the answer we got in D. And you're like, yeah, duh, of course it's not. That's not always going to be the case, though. For a discrete distribution, that's the case. If you speak more than 3 languages, that's not the same as speaking 3 or more. That's for discrete. But when we get to continuous, we're going to see those are the same. So those two are different. And then lastly, a throwback to the test you just took. Given that a student speaks more than 1 language, what is the probability that the student speaks 3? Okay, so what is the probability that they speak 3 given they speak more than 1? I want you to do this with the person next to you real quick. Take 30 seconds and do this one. This is what I got. Do you all agree?
Me and the person I worked with went to 3 decimal places since that's what everything else was, but yeah, that's good enough.
Okay. We okay so far? Yeah? Let's keep going. You should have your notes out. Oh, look. We're doing another example. Look up here. Thanks. Next thing we need to talk about is when we have these distributions, how do we find the mean and standard deviation, which you guys have already seen a little bit. One wager players can make in roulette is called a corner bet. To make this bet, a player places his or her chips on the intersection of 4 numbered squares on the roulette table. If one of these numbers comes up on the wheel and the player bets $1, the player gets his or her $1 back plus another $8. Otherwise, the casino keeps the original $1 bet. X is the net gain from a single $1, obviously that should be corner, bet. So the possible outcomes then, -1, you lose $1 or you gain $8 because it's the net gain. If the player were to make this $1 bet over and over, what would be the player's average gain? Okay, so if we just reason out how we would calculate this, if our probability is out of 38,
Is that an M or
it's a mu.
that weird U? Okay, got it.
If our probability is out of 38, let's force our player to play 38 times. The player would be expected to lose $1 34 times, and then to gain $8 4 times. This is what is to be expected. Not what happens, but what is to be expected. So writing that a little more efficiently, that -1 happens 34 times, and that 8 happens 4 times. A way to write this more efficiently, this is 34 out of 38 multiplied by -1, and 4 out of 38 multiplied by 8. So we just discovered the formula. The formula then is we take every x value, so that's the -1 and the 8, and we multiply by the associated probabilities. That's our 2 fractions. And then we add them up. This answer ends up being -0.05. -0.05. What does the negative mean to the player? In the long run, this player is expected to lose, which should make sense, right? The casino is going to be running a game where the player is expected to lose in the long run. Doesn't mean that he or she's going to lose every time, just if they play many, many times.
That's how casinos make money.
Yep. So if we go to interpret, if the player plays this game many, many times, notice the long run here is playing the game. It's not people. It's not many people. It's many times playing the game. So if the player plays this game many, many times, he or she is expected to lose 5 cents on average per game. Now, of course, it's not possible, like we talked about, to lose 5 cents on a game, but it's the average if this person were to play many times. Okay. Formula. Is it on the formula sheet? Yes. I expect to see work and an answer. So you would need to show this, the substitution, and the answer. I don't need to see the work above it. The work above it was just to find the formula. But I do want to see the formula and the substitution. How do we interpret? It is a long run average, like we interpreted above. Okay, we are going to calculate and interpret the mean number of languages in the example on the previous page. Do you guys remember how to do this on the calculator? Okay, I'll talk you through it. Okay, so doing this on the calculator, because I don't really want us to do it by hand. All of the possible values of x you're going to put in list 1. So do that right now. All of the associated probabilities you're going to put in list 2. And then when we've done mean and standard deviation in the past, we've gone to one var stats. Because yes, we have 2 lists, but only 1 variable. Our variable is number of languages spoken. And you're going to tell the calculator, my data is in list 1. And then when it says frequency list, you're going to put L2. If your calculator doesn't ask for those, it's just L1, comma L2. And the calculator will read that as data probabilities. So do that now. You should get a mean of 1.457. Do we? Yes? So I would expect on your homework, you're going to show the formula. You're going to show a substitution. So one language, 0.630 plus ... show the last one. And then you would show it's about 1.457 languages. We're not going to interpret, or all I'm going to say it, I'm not going to write it. Something like in the long run, if you were to choose a bunch of students and ask how many languages they speak, the average number would be about 1.5. Okay, does the expected value have to equal one of the possible values? No, right? 1.457 is not a possible number of languages. Should your value be rounded? No. I cannot stress that enough. On the AP test, if you get this number and then you round it to 1 or you round it to 2, you're not going to get credit, even though you had the right number. There is only one time that you round numbers, and this is not it. And we haven't actually gotten to it yet.
How many decimal places are we supposed to be rounding to?
So there's no real rule of thumb for the AP test. I do like 2 or 3. Just don't do whole number. One other thing I want to point out to you, just vocab-wise, make sure that you know expected value is the same thing as mean. So if you are asked for the mean or the expected value, those are the same. When we calculate mean, of course, the next thing that we have to calculate is standard deviation. That's what we're going to do next. Okay, standard deviation, if you remember, is S. Variance is S squared. We talked about how to do this before. To find S, what we're going to do, we're going to take every X value, subtract the mean, and then we talked about when you do that, you're going to get some positive values, some negative values. So we square all of them to get all positive. We multiply by the associated probability. We sum them all up. That gives us variance then. Then we take a square root.
Wait, what's that first one under variance? Is that
S squared. Okay, so if we use that formula for the languages data that we have right here, RS, so take the first X value, which is 1, subtract the mean, square it, multiply by the associated probability, and we would do that for all the terms. So the last one is 5, subtract 1.457 squared times 0.002. That's variance though, so we would take the square root. that should be available on your calculator. Okay, not yesterday, 2 days ago on your calculator, I told you to use S, not sigma. Can you guys look right now, when you did 1-var stats, does it give you S? No, right? It just says S and it's blank. But your sigma, it says, is 0.671
Yes.
about?
Yes.
Okay, this is the only time you use sigma. If the calculator does not give you S, you're going to use sigma. It's still a sample, so we're still going to say it's S, even though that's not what the calculator is showing. Okay. Is this on the formula sheet? Yes. Bless you. Okay, we're going to finish this page and maybe do 1 or 2 more questions on the next page, and then we will take another break. How do we interpret standard deviations? Standard deviation is the average distance the outcomes are from the mean in a large number of repetitions of the chance process. So what I mean in the case of the languages is if I took a whole bunch of students and asked them how many languages do you speak, and then I found the difference for every student between that number and the mean, the 1.457, that's called a deviation. If I average those deviations up, I would get about 0.67. We should not be interpreting that 0.67 as big or small. Sometimes students will say, oh, that's a small probability. We don't really have a way to measure big or small, so I don't want big or small. I just want to know, what does the number actually mean? Okay, so if we go to interpret it, of course, in the long run, if we sampled many students, many U.S. high school students, and asked the number of languages spoken, the number spoken would typically deviate by 0.671 languages from the mean or the average. And then I don't know if this is in your homework or not, but if you are asked for variance, which is S squared, you would take that 0.671 and square it. So the variance in this case is about 0.45. And the big difference is units. Variance is squared, so units would be squared. Now, what does language squared mean? We don't really interpret that. Okay, and then last question. Just as a reminder, when using your calculator, you need to show work. Also, one other thing. In your calculator currently, under 1-var stats, Your frequency list is L2. You need to make sure that you remove that when appropriate. What I mean is, if I gave you a list of 10 data points and said find the mean and standard deviation, you shouldn't have that L2. You should take that away, which is what is going to be the case most frequently after this point. Questions? Let's keep going. So if you could have your notes out and your calculator out still. I bet what you're thinking right now is, but what about continuous random variables? And I'm so happy to tell you that's what we're going to talk about next. Okay, continuous random variable is a numeric variable that can take on any value on an interval of a number line. So there are no gaps between the values. So for example, if I asked you, what is the length of your foot? We said shoe size is discrete because you can't have a shoe size of 8.7, but your foot could be 8.7 inches long. If I asked you the time that it takes you to do something, that would be a continuous random variable. Okay, if we take a look at foot length, how many possible foot lengths are there? There's an infinite number. If we picture graphing that, so we talked about earlier, we didn't actually do it, we talked about making a histogram. So how do you make a histogram when you have an infinite number of possibilities? What you have to do is picture making a histogram with an infinite number of really skinny rectangles or intervals. That add to 1, the area adds to 1. So if we picture taking a histogram, like maybe the one you saw in the video, and making those rectangles significantly narrower, what would that do? It's going to look like a curve. And we've seen this term before, it's called a density curve. So it's going to be a curve rather than the rectangles on a histogram. So in this case, when we find a probability, we don't have a table where we can add up numbers. So instead what we are looking at is area. Okay, for a discrete random variable, we said if you speak at least 3 languages, that is different than speaking more than 3 languages. If it's continuous, on the other hand, and we're looking at the probability that x is greater than or equal to 3 and the probability that x is just plain old greater than 3, we have to picture that we have a curve of some kind. So let's say that's our curve, our density curve. If this is our cutoff of 3, and we are looking for an area, does the area practically change if I include that value or not? No. We can't find the area at one specific value. So the probability of x greater than or equal to 3 or x is greater than 3, those two are the same. Because the boundary lines don't add area. We have one example that we're going to do, and this is the last of our notes, and then we will move on. The most common continuous distribution is a normal distribution. So this is going to be a throwback to a few units ago. The weights of 3-year-old females closely follow a normal distribution that has a mean of 30.7 and a standard deviation of 3.6. We are going to randomly choose one 3-year-old female and we will call her weight X. Find the probability that the randomly selected 3-year-old female weighs at least 30 pounds. Before we do any calculations, when we did a normal distribution, what is the first thing we had to do? There's 2 things I required you to do every time. I don't remember any of them. Okay, I'll tell you the first one. The first one is just repeat what you were given. So X is the weight of the 3-year-old. I don't so much care about that. What I do care about is you have to tell me that X is normal with a mean of 30.7 and a standard deviation of 3.6. You have to do that. On the AP test, you are not going to get credit if you do not repeat that, even though it's stated in the question. Besides doing that, what is the other thing you had to do for every normal distribution? Do we not remember or we don't want to talk? Yes.
Like draw the thing with the different.
The graph. Draw the graph. Thank you. So for the graph, we always put mean, standard deviation, 2 standard deviations, -1, -2. And then below that, I required you to put the numbers from the problem. So this is 30.7. The next one is 34.3, I think. And then 27.1. And then you have to shade and label what you're looking for. So the probability that the female weighs at least 30 pounds, you're going to find 30 on the graph. You are going to label that 30 up there. That's what most of you tended to forget before, is you would make this line and you would shade, but you would forget to put the number. Again, the AP test wants that. And you would shade. You could also write that we're looking for the probability that X is greater than or equal to 30. How would we do this in the calculator? Because now we're finally ready to go to the calculator. Distribution. So go to second distribution, and then you're looking for normal CDF. The calculator wants a lower bound, which is 30, an upper bound, which is a really big number. So I normally do 1 times 10 to the 99th, or just hit 1 and a bunch of zeros. The mean, which is 30.7, and the standard deviation, which is 3.6. When you do all of that, you should get about 0.577. Do you? Okay, if we had to interpret this, we would say in the long run, if you chose a bunch of 3-year-old females, about 58% of them would weigh at least 30 pounds. Back of the book when you guys go to check your answers. The book is going to convert this 30 to a z-score. You do not need to do that. I do not do that. As long as you have this graph and it's labeled, you don't need to do a z-score. Okay, can you all do part B? I don't need a new graph. I just want you to do it on the calculator. Find the probability that a randomly selected 3-year-old weighs between 25 and 35 pounds. I got about 0.827. Did you all get the same thing? Okay. Ideally, you would draw another graph. If not, draw it on the same graph. Just make sure you differentiate so I know which one is which. Questions on that before the last one?
When it's between 2, is it greater than or equal to, or is it just greater than?
Because this doesn't specify, either one is fine, whatever you put in your notation. Okay, and that brings up a good point to me. So Avery asked about this, the probability notation. You need the probability notation, or you need the shading with a label. Only put the probability notation if you're going to do it correctly. So on the AP test, if you have the shading and a label correct, and then you put the wrong symbol here, you're not going to get credit. So as long as you label the figure and you shade and you put that 30 up there, you're going to get credit. If you want to put that, great, but if you're not confident on the symbol, don't put it. Okay, last thing for us to talk about is part C, which is the one that's a little bit different. The probability that x is less than k is 0.8. Find k. What do we call this? I don't know if that's specific enough or not. So we're looking for this value here, so such that the area here is 0.8. In general, what is that called if you're at the value where 80% falls there or below it? What? Percentile? It's asking us for the 80th percentile. That's not what we were doing in A and B. In A and B, you were given a cut off, you were finding a probability. In C, you're given a probability, you're going backwards. So in your calculator, this is the one where you do inverse norm. Inverse norm. Some of you have the left, right, center option. Some of you do not. If you do not, it is always a lower probability or a left probability, which we happen to have here. So you would do inverse norm of 0.8. The mean is 30.7. Standard deviation is 3.6. So this is a left area, a mean, and a standard deviation. And then when you do that, you should get a weight. And based on your graph, if we're looking for the 80th percentile, we know the weight has to be greater than 30.7. So if you get something smaller, that's going to be wrong. I got 33.73 pounds about.
Yes.
You all got the same thing? That's the idea there. How do you all feel about that? We feel okay?